In this particular video, we're going to be looking at a series of chemical reactions. I have 6 different types of reaction, and we're going to be learning how to predict the products of all of these. So in our first example here, I have N2 plus H2. And we got to ask ourselves, what kind of reaction could this possibly be? And we have 2 elements by themselves, so they're simply going to join together and form a synthesis reaction. In a synthesis reaction, we just stick our 2 elements together, so the N and the H has to form some kind of compound. Nitrogen bonds 3 times, hydrogen bonds 1 time, so our molecule being formed here is going to be NH3. Pretty simple combination reaction. Some people call it a combination reaction, other people call it a synthesis reaction. Next type of reaction, we have NaCl plus F2. This is a single replacement reaction, and this is single replacement by way of halogens. In this one, the chlorine and the fluorine are going to trade positions, and the fluorine is going to bond to the sodium, so we get sodium Na, and we get F. The sodium is a +1, and the fluorine is a -1, so NaF is the proper formula. And then we have plus chlorine gas. Chlorine is written as Cl2 because it's the diatomic, one of those magnificent 7s. On the periodic table, they exist as diatomics, meaning there's 2 of them, so Cl2. Again, not a chemical reaction that's balanced, but we'll worry about balancing later. Again, the fluorine and chlorine have traded positions in a single replacement reaction. In the next one, we have lead hydroxide and hydrochloric acid. You got to learn to recognize your bases and acids. This is a base. The hydroxide indicates it's a base. The hydrogen indicates that it's an acid, so acid-base reaction. Acid-base reactions are also double replacement reactions, and it operates just like a double replacement reaction, where the lead and the hydrogen are going to trade positions. The hydrogen then is going to bond to the hydroxides, and that forms us our typical water in an acid-base reaction. And our lead is going to bond with the chlorine, so I make Pb, and the chlorine is Cl. And I need to figure out what charge of the lead I have. So over here I have negative 1 hydroxide. There's 2 of them. So the total charge on the hydroxides is a -2. So this lead must be a +2 to balance that off. So this must be +2 lead. So this is lead 2 chloride, +2. Chlorine is a -1 charge. Crisscross, PbCl2 is the proper formula for that. Next type of reaction is a double replacement reaction. And in a double replacement reaction, we have the aluminum and the potassium that are going to change positions here. And so the aluminum is going to replace the potassium and bond with the sulfite. So we have aluminum and the sulfite, just like that. Aluminum is a +3, sulfate is a -2, so we write a 2. And I'm going to do parentheses around the sulfite. And 3. So aluminum sulfite is Al2SO33. And then our other product then, the potassium, is going to join with the bromine, KBr. Potassium is a +1, bromine is a -1, so KBr is the correct formula for potassium bromide. Next reaction is a copper hydroxide, and that's our only reactant, so this is just a decomposition reaction. This is going to break down. 2 special rules I'm going to have you know is the metal hydroxide rule and the metal carbonate rule. In the metal hydroxide rule, which applies here, I have a metal bonded to a hydroxide, and the decomposition of this was that I make a metal oxide, so the oxide of copper, and then the other product is water. So our metal is copper, and it's going to make the oxide of that. Copper, what's its charge? Well, I got to go over here and figure it out. I have -1 hydroxide. There's 2 of them. So the total charge from all the hydroxides is a -2. And so this copper must be a +2 charge. So this is +2 copper, -2 oxygen. CuO is the correct formula for that. And we have our other product then is good old-fashioned water. This OH is breaking down, and we make water as our, we make water as our other product. CuO plus H2O. And last but not least, we have our final reaction. We have C2h6 plus O2. And in this chemical reaction, I have a hydrocarbon here in the presence of oxygen. This indicates a burn. This is combustion. And the products of a combustion reaction are always carbon dioxide, and our other product is water, H2O. We're always going to assume that we have plenty of oxygen gas. So if we have plenty of this, then we're going to have complete combustion all the time. We'll always assume that's the case. So here again, we have our 6 different types of chemical reaction, and we've been able to predict what those are. Hopefully this will help you in your efforts and on your homework packets. If you have any questions, ask me at school. Thank you. Have a good night.